You've probably already solved problems about roller coasters where we know at the top of the first hill of a roller coaster we're all potential energy, and then when we get to the bottom of the hill we're all kinetic energy, and then in order to get over the second hill we know we need to have just a little bit of kinetic energy left over, and because of friction and air resistance we know that H1, the first hill, has to be taller than H2 in order for the roller coaster to make it over the hill. Now we're going to look at what happens when a roller coaster goes through a loop. And it's a little bit different because when a roller coaster goes through a loop, when it gets to the top, it's got no track underneath it to support it. So if we released our roller coaster at the height of our loop, the roller coaster would not make it all around because gravity would pull it straight down. So the determining factor of whether a roller coaster will make it around a loop is that the centripetal acceleration when it gets to the top of the loop has to be greater than the acceleration due to gravity. So let's take a look at that on our roller coaster loop model. So here is our roller coaster loop model. The loop itself is about 30 centimeters in height, and to start off with I'm going to release the ball at 60 centimeters in height, and you'll notice that it makes it around the loop rather easily. Now I'm going to release one at 50 centimeters of height. Still makes it around, but just barely. When I get it to 45 centimeters in height, you'll notice that it comes off the track right near the top of the loop. And if I were to release my roller coaster car at the same height as the loop, you'll notice that it won't make it around. Early roller coaster loops were made circular, but they were not very popular because in order for a roller coaster to go around a circular loop, the person on the roller coaster would undergo a 6G change, which is not very comfortable. So modern roller coasters are made with something similar to a clothoid curve, where it starts out with a larger radius and then the radius gets progressively smaller. This way they can actually control the amount of G-force that a rider sees. So currently roller coasters are designed for a 4G max.